Hey everyone, here we are on our last section of the chapter, 8.6, Identifying Special Quadrilaterals. So what this section is about, it's taking all the stuff that we have looked at in all the previous sections and basically trying to classify quadrilaterals as best we can. And so this kind of flowchart is really kind of a fantastic way of kind of reading through the properties, okay? So everything in here has the special properties of the things that comes before it. So we start with the most generic, which are just quadrilaterals, so nothing special at all. They just have four sides. The only real property is that the sum of the interior angles is 360 degrees. And then we branch off into more specific. So the first thing we talked about is this group over here, the parallelograms. Okay, so these are the properties like the opposite sides are congruent, the opposite sides are parallel, the opposite angles are congruent, the diagonals bisect each other, stuff like that. Those get broken up down more specifically into rectangles and rhombuses. Okay. Additionally, with the rectangles, these have four 90-degree angles, and the diagonals are congruent. Rhombuses have all four sides that are congruent. Okay. And then the kind of hybrid of each of these, where you have the 90-degree angles and you have the four congruent sides, are squares. All right. So that's one kind of branch of this quadrilateral tree. The other branch is trapezoids. All right, trapezoids we did not talk about very long at all. They just have the one pair of parallel sides. Not a lot more interesting about that. There's actually far more properties that we're concerned about in the subgroup of this, which are the isosceles trapezoids. Okay, so these are a little more interesting because the diagonals are congruent, the base angles are congruent. There's just a lot more going on with the isosceles trapezoids. And then the last one is the last shape we talked about, which are kites. All right, and so kites, we had main things. You have the two pairs of non-adjacent congruent sides, and interestingly, with the diagonals are perpendicular, like they are in rhombuses. One of the diagonals gets bisected, the kind of non-tip-tail one. The tip-tail diagonal bisects the two angles, bisects the angles at the top and the bottom here for the tip and tail. And then these angles are congruent. The non-tip-tail angles are congruent. So kites have a lot of kind of very specific properties. I think kites are probably the hardest because they have properties that are kind of different in different parts of the shape, whereas everything else is somewhat uniform with their properties. Okay, so what you need to be able to do is answer a question like this. Like, I tell you that a quadrilateral has at least one part, so say pair, at least one pair of opposite angles congruent. What type of quadrilateral meets these conditions? So if you look up at the chart and you ask yourself, well, which one of these has at least one pair of opposite angles congruent? Quadrilaterals will pretty much never be the answer as far as like you saying yes to something. Quadrilaterals will be the answer to a question like this if you basically say no to every other shape and you're just left with the boring quadrilateral. So we start with parallelograms. Okay, do parallelograms have at least one pair of opposite angles congruent? And they do. The opposite angles in parallelograms are congruent. So one of our possibilities is parallelograms. Okay. And then what this also means, so therefore, because parallelograms works as having at least one pair of opposite angles congruent, all of the subsets of parallelograms should also work because everything lower on the table, on the flowchart, is also a parallelogram. Okay? So therefore, also rectangles rhombuses, squares. Okay, so we already have 4 possible shapes. And we can go over, so trapezoids. Do trapezoids have one pair of opposite angles congruent? No. So if they did, they'd actually just end up being parallelograms. So trapezoids end up being a no. Kites do. So kites have the non-tip tail angles in here. Okay, so those 2 angles are congruent. Okay, so they do have at least one pair of opposite angles congruent. So we also have kites. Okay, so we can narrow this down to 5 possible shapes. All right, is there enough information given in the diagram to show that the quadrilateral is an isosceles trapezoid? So a couple things. We have to first show it's a trapezoid, which means it has only one pair of opposite sides parallel. And then we'd have to kind of show that it is isosceles without knowing any side lengths here. Okay? So if you take a second to think about it, check on back. This one's going to be a yes. So if we look here, angle S and angle R are supplements. Okay, so because these are supplementary angles, by the converse of the consecutive interior angle theorem, we could say that PS runs parallel to QR. So we have one pair of parallel sides, okay? Now that's not enough because it could be a parallelogram, so we want to go kind of further there. If we look at these angles like P and S, angle P and angle S are not supplements. So that means that PQ does not run parallel to SR. Okay? So by just having these 2 things, we've shown that it is a trapezoid. Okay? Because we have exactly one pair of parallel sides. So to show that it is an isosceles trapezoid, we just look here that these angles are actually congruent. So we have our bases of PS and QR. Those are the sides that are parallel. We have a pair of congruent base angles. So angle P is congruent to angle S. So this is a trapezoid with a pair of congruent base angles. Okay, so if you have a trapezoid with a pair of congruent base angles, therefore it is isosceles. All right, so we talked about this the other day. That's sufficient to prove it. If you did the whole add these angles up to 360, you could find that this is 106 as well, so it has both pairs. But as long as you know it's a trapezoid, just knowing one pair of congruent base angles is sufficient there. All right, so typical thing, pause this, try it on your own, come on back. Quadrilateral DEFG has at least one pair of opposite sides congruent. Okay, so if you go back to that flow chart, you can see that this again works for parallelograms. Okay, so therefore also all the kind of children of parallelograms, so we're looking at rectangles, we are looking at rhombuses, we are looking at squares. Okay, and then if you look at your flow chart, you kind of go left to right. Trapezoids have one pair of opposite sides that are parallel, not necessarily congruent, but isosceles trapezoids have one pair of opposite sides that are parallel and the other pair of opposite sides are congruent. So we have parallelograms, rectangles, rhombuses, squares, not kites. Kites have adjacent angles, or excuse me, adjacent sides that are congruent. All right, so these questions here, I think these are probably the hardest types of questions. I think I'm gonna give you many of these to try later in the week, because I think this is the most kind of thought provoking. Like these you have to really think for some of these. So just give it a shape, classify it. So what do we have here? We have, these are 50, 50, 51, 51. So if I just kind of mark so I can see which sides are congruent, parallelograms, which are like half the shapes that we learned, have opposite sides that are congruent. This does not. This does have adjacent congruent sides, more adjacent congruent sides. So this is a kite. Okay, so the tough part is being able to explain your reasoning. So this one, though, isn't too bad, because you have this is literally just the definition of a kite. So this has two pairs of consecutive, or adjacent, I'll say adjacent, congruent sides. Okay, that's just the definition of a kite. Number 3, we have one pair of parallel sides that are shown, but that does not imply that the other ones are not parallel. So we can't guarantee trapezoid right away. So we have to look something else. Well, my diagonals are given here. Okay. So first off, I see that these are 62, 75, 64, 80. Okay. So the diagonals do not bisect each other. Okay, that means that it is not a parallelogram. Okay, so because it is not a parallelogram, and we have a pair of parallel sides, this has to be a trapezoid. Okay, but you want to check, is it an isosceles trapezoid? So what makes an isosceles trapezoid different from just a normal trapezoid? Okay. Well, if we look at the diagonals, an isosceles trapezoid has congruent diagonals. So Vx is equal to 144. Yw is equal to 137. Okay. So the diagonals are not congruent. Therefore, it is not isosceles. So we're just going with a normal trapezoid. Third one here, we have, looks like we have a lot, but let's just go down. So we have one pair of opposite sides that are congruent. So already that could be a parallelogram, could be a isosceles trapezoid. We have one pair, we have a diagonal being cut in half. So this part's 9. So if this is 9, these things are congruent. This thing you don't know. Okay, so if I knew that was 9, I could get away with calling this a parallelogram, but I don't know what this is. There's actually nothing that we can tell you. There's no way of guaranteeing that any of these angles are congruent. There's no way of fixing any of the sides. You can kind of see this. So even if we put in these like vertical angles here, okay, if you tried to like prove some other pieces, okay, you can always do this by thinking about triangles, because we know a lot of stuff about triangles already. So if you just use these vertical angles in here, and you look at kind of the pieces of these triangles, so like if I look at these two triangles, the top one and the bottom one, the parts that I know are side angle, which we know is not a congruence theorem. So there's like some ambiguity with how this shape could actually be. Okay, so you can't just trust what's on the paper. There's actually some ambiguity with how this could go, because we know that side angle is not a congruence theorem. And if you look at the two triangles left and right, you get the same thing. So you'd have these vertical angles again, vertical angle, and again you have angle, side, and then this is angle, side, thing you don't know. So you don't even have angle, side. So there's just a whole bunch of info that doesn't lead to really anything here. So this is just a quadrilateral. Okay. There's no reason. There's nothing specific to get us anywhere else. All right. Last question here. Student knows the following information about quadrilateral MNPQ. MN is parallel to PQ, and P is congruent to Q. the student concludes that it's isosceles trapezoid. So just draw yourself a quadrilateral, and let's see what we have going on here. So I have M, N, P, Q. MN is parallel to PQ, so we have MN parallel to PQ. So good start. So the student says trapezoid. We see one pair of parallel sides, so that's a good start. P is congruent to Q. Okay, so you have a pair of parallel sides. These would then be the base angles. So congruent base angles would make this isosceles, no? Well, even though I only see one pair of parallel sides, okay, without knowing the relationship between the other sides, namely MQ and NP, okay, this shape could be a rectangle as well, right? Rectangle or square, okay? So if these sides were also parallel and these angles were congruent, this would be a rectangle, okay? I mean, it could be a square as well, but the fact is, to conclude that this is an isosceles trapezoid, we would have to know that these sides were not parallel. If we knew these sides were parallel, it would make this at least a rectangle, okay? All right, so the practice on this is, I believe, harder than it looks. I think this, but if you follow through this flow chart when you're going through the work, do the best you can. You might have to go back to previous day's notes to get all of the properties, okay, especially with the diagonals. There's kind of a lot to keep track of, okay? Good luck. Email if you have questions. Maybe I'll see you guys on Friday. Take care. Hope everyone's doing well.